you're gonna have to go, well, lastly, it's not the last part, there is also a part 5, but you're gonna have to go now into part 4, which gets easier and easier because now you have introduced the reader on how you actually find quadratic functions from given diagrams. So part 4, you're gonna have to choose the bridge, a real life big bridge of your own taste. So this one is the Danish one. You can see if we had to draw it, let's see. Again, you would have to put 2 axes like this, and this one will be in meters, and also this one is in meters. You're gonna have to use software, it says, to draw the cable, but first we're gonna have to model the cable above the main deck. Let's see. You can see that the pylons are 255 meters tall, and the distance to the sea is 70 meters. So if you take 255 and you subtract 70, it's 185. So this number here, it would be 185 meters. That's the distance from the highest part of the pylon to the deck level. Now it says that this sags at a 0.3 meters above the deck. So imagine that this one is gonna fall down to 3 meters. So imagine that this point here is at 3 meters above the deck. And then, of course, it rises back. Oops. I'll just try and do it here. And it goes again up at 185 meters. And the span is 1,625 meters. That is how wide the central span is. So you can understand that this minimum point, it's going to be at exactly half the 1,625 meters. If you divide that by 2, you will get that this point is at 812.5, so right in the center. Okay. This piece of information, well, let me just write, this is part 5. We need to fit the function. You start again, y equals a x minus h squared plus k. Y is a times x minus, and now the h coordinate, the x coordinate of the vertex is 812.5 squared, and all squared, yeah, plus the k is only 3. We're almost there. We also know that when x is 0, y is 185 meters. So we put that into action. 185 is a 0 minus 812.5 squared plus 3. Well, if you subtract 3 by both sides, it becomes 182 equals a times. If you take 812.5 and you square it, you will get a number which is approximately 660, something, okay? I'm gonna leave it to 660. 660,000 actually, so maybe I should write the whole thing. 660,156.25. That's what you will get if you take this to the power of 2. So the A is going to be 182 divided by this number. So you get a number for A that is going to be 182 divided by 660, 156.25, you get 0.000027569. Of course, this is not a really nice number to carry around, so we can write it as, in three significant figures, 2.76 times 10 to the negative 4, because now it looks prettier. Now, using this value for a in three significant figures, you can write that your y, the function that models the cable of the Danish bridge above the deck, is going to be 2.76 times 10 to the negative 4 bracket x minus 812.5 squared plus 3. This is your function. But in real life, when we write down a function, because of the fact that functions have domains, and of course x represents length, y represents height, we need to write down the domain that it happens at. For instance, x such that x is from 0 to 1625. This is your domain. And yeah, that's the process of basically modeling the height of the cable above the bridge. And you know what to do next. You have to go on Desmos, and you have to enter, again, you have to put your function nicely and show it here. And then the project, when you have your actual function, it continues with questions that could be answered by using the function found. For example, let's see this one. A car is driving on the bridge in January. Ice hits the car and damages the roof. The driver notices that the car was 200 meters past the pylon when the ice hit the car. How far did the ice fall? That means that if you look at this graph here, and you go 200 meters in, maybe here, somewhere here. The question, well, I'm not going to write meters because I already wrote that this is in meters. If you go 200 meters here, what was the height from which the ice fell? And that can be found easily. You just have to go and write y equals 2.76. That's approximately, right? Because that's also approximate. Times 10 to the negative 4, 200 minus 812.5 squared plus 3. And you will find the approximate height that this happened. You can put it in your graph now because you know it. It will be probably somewhere around 100 meters. Let's see. Or answer another question. It says a helicopter is flying. Let me just clear my graph from the red inputs here that I have. Oops. Oh no. 2 seconds. Now it says a helicopter is flying at a height of 180 meters. Okay. Above the sea level and wants to fly between the pylons to get a good view, so that it does not fly into the cable. The pilot needs to know how many meters away from the pylons they should fly. Advise the pilot. So you basically, let's say this is the height at which maybe I'll do it with this line. That's the height at which the pilot wants to fly. Let's suppose this one is 180 meters. So it says, well, the pilot doesn't want to go on the cable. So what is basically this value here? What is the x? Between which value and what other value the pilot can fly? How can we advise the pilot? Well, in those cases, it's y that is 180, right? So we could go ahead and we could write, sorry for the clicking, I need to get it off. So in this case you would say, well, y would be 180. So you write 180 equals 2.76 times 10 to the negative 4, x minus 812.5 squared plus 3, and you're going to have to solve for y. The way you can do it is by using your calculator or by, your TI-84. If you use your TI-84, you will be able to find x in that case. Yeah? Or you could also go here and graph your function and find the x at which this happens. So let's say that we have found x to be, let's just draw the lines. Let's say that we have found x to be between 50 and let's say this number was, just remove this, 1,575, and we said that this one is the 1,625. Let me just do the calculation, 1,625. Yeah, so then you would have to say, well, the helicopter can fly anywhere in between here. So I would advise the pilot to fly for x being between 50 and 1,575 meters, for example, because then the pilot would fly there. You can come up with your own examples or problems and try and be creative with this project. But that was more or less the fourth part of the project.